Hello CS211 folk, I hope you're enjoying your snow days. This video is intended to get you up to speed on the scanner class, which you'll be required to use in order to complete Lab 2. There will be a second video that gives a brief introduction to the classes that are in Lab 2, but this one will focus on using Scanner in order to get input from various sources. On the screen you should see a Dr. Java setup, and I'll be using that in order to illustrate some of the features of the scanner class, and this code is in your lab pack distribution in the scannerdemo.java file. So the first thing you should know as we get into the broader realm of using classes, you'll need to import classes from the standard library. Java has these, but doesn't make them available by default. What you'll need at the top of the file, probably your treasuremap.java file, is an import of the scanner class, which is just simply says import then the package name where scanner lives, which is java.util, and the scanner class itself. We'll also be taking input from a file source, so you'll need the java.io.file class, so import that as well. At the top of this file you'll see the scanner demo and also a declaration of a public static void main method. That's nothing new. However, this bit is throws exception. So this is an admission to the Java compiler that during input things can go wrong, and that stuff that can go wrong takes the form of methods that can throw exceptions. Since main will be potentially running into trouble, it also has to admit something could go wrong. These will be I/O and parsing based exceptions. However, I'll be lazy at this point, not specify exactly what kind of exception, but just say I could throw one. This is something that we'll refine later on in terms of understanding once we get to exceptions and inheritance. For the time being, take it as an article of faith that in order to satisfy the compiler, you'll need the following line: throws exception after main and before the curly brace. So down here is where the action really gets started. Since we've imported a scanner, we can actually start using one by declaring I need a local variable that points to a scanner, and then allocating one via a constructor. Scanner has a couple different constructors, and here's the one that we'll start with. It takes as an argument an input stream, and the input stream we'll feed it is system.in. Most of you should be familiar with system.out, which is an output stream. We call its printline method and printf methods fairly frequently. It has a counterpart, system.in, which allows one to take input from the terminal. It manages stuff that comes into the program as it's running based on the terminal where it is running. So this particular constructor, scanner and passing it in system.in, says the scanner that we'll point at is going to take its input from the terminal, so the user can type things in to communicate with the program. Usually when you want input, you should print informative prompts. That's what we'll do next. Use that system.out.print in order to print a message to the user that we desire an integer from them. Next line instructs the scanner input, that's the name of the object that we've created, to call its nextInt method. NextInt is going to wait on the user to type some integer in and then press enter. And once that's done, we'll parse the string that's given, convert it into a binary integer, and then return that so that it can be stored in a local variable, in this case I. Next we'll ask for a real number and correspondingly expect a double to come in. Remember, real numbers are fractional, and double is one of the types that Java uses as a primitive to deal with that. Scanners can read doubles by using the nextDouble method. So here's us asking the user for a real and then parsing it using input.nextDouble. Finally, we'll ask for a string from the user by prompting, and then calling the input.next. This is the next method of scanner. So this breaks the pattern a little bit, and that one might expect it to read next string instead, but instead this is just next. All things for input can be read as strings, though I would probably argue that breaking the pattern in this way is not so good. So once we've read those three things, we'll print out the results of I and D and S, and let's compile and run the scanner demo in order to see and make sure that all is well. So compile works fine. This message here is informing us that right now I have a data file open. We'll deal with that next, and it can't be compiled, but that's fine. So I'll run the scanner class as a main method, and lo and behold, prompt is printed, and the program stalls, waiting for us to type something in. Here's a fine integer, 1, 2, 3. Next prompt that we wanted to print, input a real, is also printed. Dr. Java is recognizing the fact that we want input and putting these nice boxes up here as a sort of indication. So I'll put in 4567, 4.567 as my real, and a string, how about hello. This will do a bunch of things, but what we're most interested in right now is this line, which prints out what we just read in, and lo and behold, we have indeed communicated to the program what those 3 pieces of information were. So scanners aren't just good for getting input from the user. Instead, they can use a different source for data. In this case, we'll be reading from a file. So same sort of basic setup. We have a local variable input, which is a scanner waiting to point at 1. We'll call it the scanner constructor, but instead of passing in system.in, this time we'll pass in a file. Capital file is a class in Java, lives in the java.io package, and we can construct them using a string. And the argument to the file constructor here is the name of the file that we want to deal with. I have a file in the lab02 pack distribution that you guys can use called data.txt. It looks like this. There's some string information, some numbers at the top, several lines of text to deal with, and we'll first deal with that first line. So what this is going to do is look in the current directory for a file named data.txt. It doesn't exist, expect to get an exception, but if this constructor is successful, we'll pass that file into the scanner, and instead of reading from the user, now the scanner is going to read from the file. Instead, the same methods work as did for user input. I can ask next for the next string, next int for the next integer, and next double for the next real number. I'll ask for 4 of those things, a string, an int, a double, and then another string, and use my handy system.out.printf to print formatted versions of that. Recall, we can print real numbers up to a certain precision using printf and a format specifier. In this case, 0.3 will print the double to 3 digits of decimal precision. So let me compile, run that again. So I'll put in some garbage for the scanner to read for the initial stuff. Down here, though, is where we're printing out things that were hopefully read from the file. Printing out A string, 22, 0.988, and B string. Notice the parsing. Up here is the data file that I read, and A-string exclamation mark was read in its entirety by the scanner.next call. So by default, scanners will separate input tokens by space. You can have as many spaces as you like in order to separate tokens, but non-space characters are all considered part of the same string. This is interesting if you're trying to do something like read first and last names. You have to make 2 calls to the next call. So the first string read was A string. The next number that was read was 22. That's down here. The next number that was read was a real number, 0.98765, printed as 0.988 because of the rounding to 3 decimal digits, and finally B string, including the ... The final bit that is in the scanner demo is a demonstration of reading files in their entirety. Now, one quick caveat. When you're dealing with files, it's good practice to close them after you're done. So if all I wanted was the first line of this file, I would, at this point, call input.close, which frees up any operating system resources associated with an open file. In order to reset the position of the scanner back to the beginning, I'll simply allocate a new file and a new scanner based on that new file, which will point input back at the beginning of data.txt. Finally, a couple extra methods. When reading input in a loop, you oftentimes want to know, is there any input left? Scanners can answer this by saying has next, which turns a boolean, true if there's anything left to read, or false if there's nothing left to read at all. There are also associated next int, next double, and a few other type methods like that if you're particularly interested in numeric stuff. But most of the time, we'll use has next to indicate there is something left to read. If I want a whole line of text rather than just individual single space separated strings, you can call the next line next line method, which will read a whole line of input. and return it as a string. Here I'm simply printing out each line, %s for the line s that was read, along with its associated line number, incrementing I as I go along. So this loop will run until there is no input left. It will read entire lines and print them out as it goes along. And when done, we'll close the file. If you have a look at data.txt, the first line reads as we saw before, when you have a line number 2, line number 3, and an all done now. These are repeatedly read in and then printed out with a line number. Line 1 looks right, line 2, line 3, line 4 all looks well. This is a crash course on Scanner. Things to keep in mind. You can get input from the user by creating a scanner that takes system.in. You can create a scanner that reads from a file by passing in a file argument instead. But remember, it can't just be a string argument, it has to be a file argument. So import both of those up here, scanner and file, if you're going to be reading from a file. And remember the methods next to read a string, next int to read an integer, next double to read a real number. You will also probably need to use hasNext to check if there's any input left, and when you're reading a whole line, call next line. Look for another video that introduces the other classes associated with Lab 2 shortly.